Hello everyone, welcome to my channel. Towards the end of the previous video, I explained how we determine the determinant of a 2 by 2 matrix. Now in this video, I want to look at the application of determinants, basically solving systems of linear equations by using what we call Cramer's rule, and that concept, Cramer's rule, applies determinants. So we're going to be working out determinants of 2 by 2 matrices and then using the determinant to determine or work out the values of the unknowns x and y. So let's look at the first one then. The first one is 2x minus y equals 3, and then we have x minus 3y equals 4. We're supposed to solve these two equations simultaneously by using Cramer's rule. Let me capture the question exactly how it is. We have 2x minus y is equal to 3, and then we have x minus 3y is equal to 4. Now, we convert or transform these two equations into one matrix equation as follows. We have what we call the coefficient matrix, and then the matrix of the unknowns, and then the matrix of the solution at the end there. So coefficients of x are 2, 1. If you see there's a 2 and there's a 1 there. Coefficients of y are minus 1 and then minus 3. And then this one here is going to be the 2 by 1 matrix of our unknowns. So we have x and y, and then at the end there it will be a 2 by 1 matrix of our values on the right hand side of the equations 3 and 4, like that. Now what Cramer's rule basically says is that if you want to find the value of x, replace these numbers, which are coefficients of x, by these two numbers, and then take the determinant. The answer divided by the determinant of this matrix here, which is called the coefficient matrix. So what am I saying? I'm saying x is equal to, replace these two numbers by those two numbers, because what we want to find the value of x. So we're basically saying replace those two numbers. So we have 3, 4, and then these must stay the same. Coefficients of y must stay the same. Minus 3. Remember last time I told you that the two vertical lines represent the determinant all over determinant of the coefficient matrix. So we keep it the way it is, 2, 1, and then minus 1, and then minus 3, like this. Now, what does this mean? Remember, the product of elements on the right diagonal minus the product of elements on the left diagonal. So this is going to be equal to 3 times minus 3, and then minus 4 times minus 1. And we're saying this is divided by product on the right diagonal, product of elements on the right diagonal, 2 times minus 3, and then we're saying minus product of elements on the left diagonal, 1 times minus 1. Now, let's look at the numerator. That would be minus 9 if you check, and that would be plus 4. We're dividing this by, that would be minus 6, and that would be plus 1. If you continue with this, you will see that this is actually minus 5 in the numerator all over minus 5 in the denominator. And what does this give us? It gives us 1. Now, to determine the value of y, we repeat the process, but remember what we say. If you want to find the value of x, the coefficients of x must be replaced by these numbers on the right hand side. Now I want to find y. The coefficients of y must be replaced by those two. So the coefficients of x must stay the same, 2, 1. But now instead of having minus 1, minus 3, I'm going to have those numbers there, 3, 4. And then I'm going to say this divided by the determinant of the coefficient matrix, which is basically 2, 1, and then minus 1, minus 3. We know the answer to this expression here, the determinant of the coefficient matrix. We know the answer is minus 5. But let's work on the numerator. So that's going to be 2 times 4 minus 1 times 3. Remember, the product of elements on the right diagonal minus the product of elements on the left diagonal. We're doing the same in the denominator. Product of elements on the right diagonal, which is 2 times minus 3, minus product of elements on the left diagonal, 1 times minus 1. Of course, like I said, the numerator there, it will be 8 minus 3. In the denominator, this, if you simplify, it will give you minus 5. What do we have in the numerator? It's 5 all over minus 5. And what is our answer? Minus 1. So we're basically saying that x equals 1, but y is equal to minus 1. So these are the values of the two unknowns, x and y. Now, you can convince yourself by substituting these values back into the original equations and proving that indeed these two values satisfy those two equations. For example, let's just try the first one. X equals 1. If you put 1 there, 2 times 1, it is actually 2. Y equals minus 1. If you put minus 1 here, it will be minus minus 1. So that will be positive 1. But 2 plus 1, it gives you 3. So you can do the same for the second equation there. 1 minus 3 times minus 1 is 3. 1 plus 3 is equal to 4. So these answers work or satisfy the system of equations. Let's look at the second system of equations that we have to work on using Cramers rule. I'm repeating the concept so that you fully understand what Cramers rule is all about. There is a second system of equations. Again, two linear equations in two unknowns. Solving that system by using Cramers rule is done as follows. Number 2. So we're saying minus x plus y equals 2. And then we have 2x minus y is equal to minus 3. Now, transforming these equations into a matrix equation as follows. We have a coefficient matrix, and then a matrix of our unknowns, and then a matrix of our numbers on the right-hand side. Here we have 2 minus 3, those numbers. Coefficient of x, we have minus 1 in the top equation, and then 2 in the second equation or bottom equation. Coefficient of y, we have the coefficient of y up there is 1. The coefficient of y in the second one is minus 1. And obviously we have 2 by 1 matrix of our two unknowns. Now, x, Cramer's rule says, replace these two coefficients of x with those two values on the right hand side. So 2 minus 3, and then keep these coefficients of y the same. And then we're dividing this by the determinant of the coefficient matrix, which is basically minus 1, 2, and then 1 and minus 1, like that. What are we saying? The product of elements on the right diagonal, and then minus product of elements on the left diagonal, all over product of elements on the right diagonal minus 1 times minus 1 minus product of elements on the left diagonal 2 times 1. Let's work on the numerator. That will be minus 2, and that will be positive 3, because minus times minus is positive. In the denominator, that will be positive 1, and that will be minus 2. So in the numerator we have 1, in the denominator we have minus 1. What's our final solution? Minus 1. That's the value of x. Working out the value of y, repeating the same process, but this time we have to replace these ones, which are coefficients of y, replace them with these ones here. So we have now minus 1, 2, coefficient of x should remain the same, but now we have 2 minus 3 there, replacing the coefficients of y. In the denominator, we still have the same coefficient matrix, and we're dealing with the determinant of the coefficient matrix, minus 1, 2, and then 1, minus 1. We know the result of the denominator. Numerator, product on the right diagonal, product of elements on the right diagonal minus product of elements on the left diagonal. The denominator, we've seen it already up here, that it reduces to minus 1. So what does this give us? Minus 1 times minus 3 is positive 3, and then we have minus 4 all over minus 1. Obviously, you can see that's minus 1 over minus 1, and the answer is 1. What are we saying? We're saying basically that x equals, therefore, x equals minus 1, comma, y is equal to 1. These are the values. Yet again, substitute these two values into the two systems, into the two linear equations. You'll see that these numbers truly satisfy those two equations, right? You can also solve these equations by using conventional methods of solving simultaneous equations, and then checking if the answers agree with my answers, right? Let's move on to system of equations number 3. We have number 3. It says here, here's number 3, 5a minus 2b equals 3, and then we have a plus 3b equals 4. The unknowns have changed now, so but the process stays the same. That's why mathematics is, someone can argue and say maths is easy. Another one can disagree, but I find mathematics very interesting and easy to work with, because methods usually do not change, right? So we have 2b is equal to 3, the first one. The second one, a plus 3b equals 4. Someone can disagree with my opinion, but that's just my opinion. I've always enjoyed maths. Yeah, I've always enjoyed studying and practicing maths. All right, so transforming this equation into a matrix equation, we're going to have the coefficient matrix and then a matrix of our unknowns, and then on the right hand side we have the matrix of our values on the right hand side of the equations. That's 3, 4 here, and then we are going to have 5 there, 1, and then minus 2, and then 3, and then obviously a, b. Remember our unknowns now are a and b. So Cramer's rule, what does it say? If you want to find the value of a, replace the coefficients of a by this or with these two numbers. So it's going to be 3, 4, and then coefficient of y must stay the same, minus 2, 3, and I'm going to divide that by the determinant of the coefficient matrix, which is 5, 1, and then minus 2, 3, like that. Let's work on the numerator. The product on the right diagonal, remember, minus the product on the left diagonal, all over. Same story. The product on the right diagonal, that's your right and that's your left. So 5 times 3 minus product on the left, 1 times minus 2. The numerator, that would be 9 plus 8 all over 15 plus 2. And the answer is 17 over 17. You can agree with me that the answer is 1. Right. Let's work out the value of b. We do the same. B is going to be equal to, remember now, it's the coefficient of b that must go. So we're going to have 5, 1, and then we have 3, 4, like that, and then divided by the determinant of the coefficient matrix, 5, 1, minus 2, 3. We know the result in the denominator, but in the numerator we have 5 times 4, product of elements on the right diagonal minus product of elements on the left diagonal. We're dividing that by this one here we've already evaluated up there is 17. Now that's 20. 4 times 5 is 20, minus 3 times 1 is 3, all over 17, and the answer is, if you like, 17 over 17, and yes, the answer is 1. So what are we saying basically? We're saying therefore a is equal to b is equal to 1. These two guys have the same value of 1. Now again, you can put 1 where there's a, put 1 where there's b, and convince yourself that our solution here is correct. Now let's look at our last system of linear equations. I have been focusing only on two equations in two unknowns. So now we have 4. We have 5w minus c equals 6. The other one is 2w plus 3c equals minus 1. Transforming these equations into matrix equation, we have the coefficient matrix, which will have 5, 2, and then minus 1, 3, if you follow what I'm saying. 5, 2, minus 1, 3. And then we have w, c there, our unknowns. This will be equal to 6 minus 1 there. How do we find w by Cramer's rule? We're going to say this is equal to, remember, the coefficient of w must be replaced by those numbers, 6 minus 1, and then minus 1, 3. And we're dividing this by the determinant of the coefficient matrix, which is 5, 2, minus 1, 3. What are we saying? We're saying product on the right diagonal, 6 times 3, minus product on the left diagonal, minus 1 times minus 1, all over 5 times 3, which are elements on the right diagonal, minus the product of elements on the left diagonal, which is 2, and minus 1, multiply the 2. So what do we have in the numerator? This is 18. Remember there now we have minus 1, minus 1. So minus 1 times minus 1 is 1. So this is just minus 1, because there are 3 minuses, 1, 2, 3. The resulting is sign is a minus sign. All over there is 15. And then here we have plus 2. If you check, this is exactly equal to 17 over 17, and the answer is 1. Now let's work out the value of c. Value of c is going to be equal to, watch this, coefficients of w must stay now, but the coefficients of c must go. We replace them with that those numbers on the right hand side there, and we're dividing this by the determinant of the coefficient matrix, which is 5, 2, minus 1, 3. We know the answer in the denominator, but in the numerator we're saying product on the right diagonal minus product on the left diagonal all over. We know the answer in the denominator is 17. Now, this is minus 5, and there it's minus 12 over 17. Obviously, you can see that this is actually minus 17 over 17, and the answer is minus 1. So what are we saying basically? We are saying, therefore, our W equals 1 and our C equals minus 1. These are the solutions to these two equations that we had here. And we've repeated the process of determining the values of unknowns by using Cramer's rule. In my next video, I'm going to talk about what if you have a system of 3 linear equations in 3 unknowns. We will be required to work out the determinant of a 3 by 3 matrix, which I will explain how we do it. Now, like I said at the beginning, if you're new, I think I said it, if you're new to this channel, please support us by subscribing and liking these videos and sharing them. It will help us to grow the channel and give us the ability to generate more videos and support as many students as we possibly can. Your feedback is vital in our preparation. We want to take every concern or idea on board as we present these videos, because you are the people that need this information, and so we want to try the very best we can to present in the best way that we can. All right, see you next time.